Welcome, game developer hobbyists! Before I hop into the GitHub REST API, I have a bit of exciting news to share, as I recently resigned my full-time software development position in order to focus on content creation and independent game development. I've started a brand new website over at RileyEntertainment.com, which I'll be building up over the next few months. This site will act as the main hub for all my game-related content, along with game development guides, and a few of my other side projects. I also started a web development blog over on Medium, and plan to start a separate game development blog soon. So check out my website, and keep an eye on this channel for ongoing updates. I plan to keep visitors of my website as up-to-date as possible on the status of my upcoming game projects, preferably without duplicating effort on both GitHub, using issues and milestones, and on my website in HTML form. Thankfully, GitHub offers a comprehensive REST API that you can tap into for exactly this purpose. My web host most readily provides PHP support, so some of the specific examples you'll see towards the end of this video will be in PHP. But most of the information here is platform independent, so you should be able to adapt to your language of choice. So what can you do with the GitHub REST API? Looking at the extensive list of resources available on the reference guide, the answer is pretty much everything you could reasonably expect, and probably some things you didn't know existed. For the Riley Entertainment website, I'm making use of the Issues and Repositories features of the API. I've started with panels on the homepage listing recent and upcoming improvements to the site. These particular panels are querying the milestones from a private GitHub repository. The Getting Started guide on the GitHub API site provides a good introductory walkthrough using the command line tool called curl. Most operating systems already have curl installed, and it comes packaged with Git and other utilities. But if you don't already have it, the download page of the curl website has binaries available. Using curl, you can query the root URL of the GitHub API at https://api.github.com. This will respond with a JSON object listing all the available features and their corresponding base URLs. You can then check on your user profile by following the user URL. This responds with a JSON object providing your user details, along with another set of available features with their corresponding base URLs, and so on, spidering out to discover more available features. The GitHub REST API also allows you to authenticate under your username, giving you access to a wider set of features. To do so, you'll need a personal access token. You can generate one by logging into GitHub, going to Settings, then Developer Settings, then Personal Access Tokens. Here you'll give it a name, an optional expiration date, and a subset of scopes to define access to additional features. If you only plan on accessing information that's already publicly available on the GitHub website, you can ignore the additional scopes. You can see here the response when you attempt to access a URL that requires authentication. Once you have your token string, you can test it out with curl by setting the authorization header. The headers that are sent both with your request and the response are an important part of the GitHub REST API. You can see the full header information with curl by adding --verbose on the command line. Looking at the headers sent with the request, note that curl automatically includes the user agent header. It turns out this is a requirement of the GitHub REST API, and it turns out it's very worthwhile to read the overview section in the GitHub documentation, as this is where you'll find out about this, along with a number of other important headers. The accept header can be sent to specify which version of the API you're accessing. As of August 2021, this is version 3. There is a fourth version, but it follows the GraphQL API, which is a whole separate topic beyond the scope of this video. The GitHub REST API responds with a set of X rate limit headers, used to control the number of requests any one client can perform within a given amount of time. When comparing unauthenticated requests to authenticated ones, we see that the limit is much higher when authenticated. So even if you only plan to access information that's publicly available, it's still not a bad idea to go through the process of generating a personal access token. Since the Riley Entertainment website is public-facing, these rate limits raise the potential danger that visitors to the site could start running into 403 errors. If I ever get that much traffic. So, to deal with this potential, the Github REST API also allows you to send conditional requests. Responses return an ETag header, so you can cache the response data along with the ETag string, and just use the cache data whenever your call comes back with a 304 response code. Such requests do not count towards your rate limit. To take advantage of this, include the if-none match header with your request. An alternative is the if-modified since header, if you prefer to compare by a timestamp over the ETag string. The Site Improvements panels on the home page of the Riley Entertainment website were implemented in PHP by querying the GitHub Milestones API. PHP provides a full client URL library that can be used to perform the GitHub API calls. Because the GitHub API is only available on a secured connection, you'll need to make sure you set up PHP to use a valid certificate authority. You can create your own certificate chain, or go the easy route and grab the latest Mozilla certificates from the curl website. There's a curl.ca info property in the php.ini file that you'll need to set to the path of the certificate file. I started out my PHP implementation by building a small library of utility functions specific to the GitHub REST API. This GitHub request headers data structure contains properties for each of the request headers that are important for most of the calls I'll be making. The createHeaderArray function accepts this and generates an array of header strings that will be passed to curl. And likewise, the GitHub response headers contains important response headers. The bulk of the work happens in this perform_get function. This initializes a curl handle, then sets up the necessary curl options. The follow location option will ensure curl automatically follows any redirect URLs that GitHub responds with. The return transfer option ensures the response body is returned as a string. The HTTP header option passes in our request headers. And the header function option makes sure all response headers are processed and stored in a dictionary-style array. The key will be the header name, trimmed and converted to lowercase. The value will be an array of string values. The request is then executed. If successful, the response code, headers, and body are captured in the return data structure. If it failed, the curl error is captured instead. With this set of utility functions in place, making API calls without dealing with caching results becomes fairly straightforward. You would build your URL, make the call, then process the result however your application needs to. In my case, I have a repo milestone details data structure where I'm storing the milestone properties that I plan to use. I'll be displaying the title and description, either the due date or close date based on the current state, and a progress bar based on the number of open and closed issues in the milestone. Figuring out how to use the ETag headers to cache the results is the tricky part. If you're building this for a public-facing website, and you think you might be getting thousands of page loads every hour, then it's something you'll definitely need to take care of. My general approach is to maintain the cache as a map. The key is the URL, and the value is the ETag plus the full response as a JSON string. When a request to the website is made, the implementation will first check for a cached entry for the given URL. If it exists, it will add the if-none match header to the request using the ETag value. As long as the milestone data hasn't changed since the last request, the GitHub API should respond with the 304 not modified, and you can use the cached value without it counting towards your rate limit. My specific implementation was definitely not the best, but it does work. At some point in the future I plan to learn about PHP's database extension libraries, at which point this data will just be stored in a MySQL database on the web server. Until that day, I chose to store the cached data in JSON files on the web server. For anyone planning to do the same thing, a few tips you'll want to know about. First, the PHP flock function can be used to make sure only one process can update the cache file at the same time. And second, you should know that calls to the file size function for the same file name get cached. If a single PHP script has the possibility of accessing the cache file more than once, this means it might return the wrong value after the first call. You can use the clearstat cache function after saving the cache file to fix this issue. If you want to see more of the PHP source code for my implementation, you can find it over on my Riley Entertainment web dev blog on Medium. The link is in the description box below. I plan to use everything I've just presented to keep the game dev section of the Riley Entertainment website up to date with the progress of my next game, the Colon Case. So hop on over to RileyEntertainment.com to check it out, and for more of my content.